Check it with your table, please. Have a discussion about it. Compare what you got. Okay, let's take a look at number 7. So, is sine the x value or the y value? The y value. So I'm going to go find everywhere where my y value is equal to negative square root of 3 over 2. So where did you find that at? Pi over 3. 4 pi over 3. All right, so 4 pi over 3 down here. Where else? 5 pi over 3 was also an answer. So 4 pi over 3, 5 pi over 3. All right, tangent. That one was a little bit different, right? We probably had to think a little bit on that one. We're looking where everywhere where tangent would be -1. What's tangent? It's another way to think about tangent. Sine divided by cosine. Good. So I want that to equal -1. So I'm really looking for places where it's the same value. So what's going to be in the numerator every time on the same value ones? Just 2? Square root of 2, right? So I'm really examining all of these, right? Which ones are going to make it? So we got to find the ones that are going to make it negative. So which ones are going to make it negative? Not right. So it's 3 pi over 4 and 7 pi over 4, because there I would have square root of 2 over 2 divided by negative square root of 2 over 2, or vice versa, right? It could be the -1 on top. Okay. Any questions about solving the equations? That should have been major review. Okay. I think we got one more trig question in there, and then we'll go back up to the algebra stuff. Is there just one more? Oh, we've got way more than I thought. Okay. All right. Cosine. So we've got cosine of theta equals -12 over 13. It's telling me that we are between pi over 2 and pi. So here I would probably dig out this and try to draw myself a picture. If I am between pi over 2 and pi, what quadrant am I in? Good. So we're in this quadrant. I'm going to draw myself a nice little triangle. There are more than one way to do this. I could do this with triangles. I can also do it using the Pythagorean identity, the reciprocal identities, and the quotient identities. Okay, so it's up to you. I'm going to use triangles because that's probably the easiest thing to refresh our memory on quickly. Okay. All right, so here's my theta. What is the cosine ratio? But I think SOHCAHTOA. What over what? Adjacent over hypotenuse. So my adjacent leg is 12. My hypotenuse is 13. We have a problem. What was it supposed to? Which one is negative? Adjacent, right? The 12, because look, it went in the negative direction to be in that quadrant. The other hint is your hypotenuse will never be negative. It's been a really long time since we've done one of these, right? Really long time. All right. What does my other leg have to be? Something 12, 13. If I don't know, what do I have to use? The Pythagorean theorem. He's over there posted with hearts. Remember, he's my favorite. Okay, don't tell my husband. All right, so x squared plus -12 squared equals 13 squared. So x squared plus what's 12 squared? Good. And 13 squared? Good. All right, I have to subtract. What do we end up with? Good. And when we're doing a geometry-like thing, we don't worry about I guess technically it's plus minus. We could worry about it because there is a directional thing going on. Do I want the positive or the negative, though, for this leg? Positive, because it was going up. All right. Now that I have that, it shouldn't be hard to get cotangent, right? In SOHCAHTOA world, what is cotangent? Okay, that's identities world. What about SOHCAHTOA world with triangles? Adjacent over opposite. And remember the signs are posted, the little love sign, the little love note signs, right? So adjacent over opposite. What's on the adjacent? I'm sorry. Yeah, what's on the adjacent leg? 12. What's on the opposite leg? 5. That's why we had to find that other leg, right? It's because we needed it for the cotangent part. Okay. I want you to take a minute, try number 11. So you're trying this one. Okay. I want you to check it. However far you've gotten, check it with your neighbor. Okay. What did we end up getting for our third side? Should have been 8, right? Because when we do Pythagorean theorem, we subtract, we get 64. So we get x equals 8. Should it be positive 8 or negative 8? Why? Yeah, it's on the down, right? So we want it to be negative. All right. I got secant because it was what? Hypotenuse over adjacent. So I put the 17 on my hypotenuse, the adjacent on my leg there, or on my adjacent leg. All right. So to get sine, what is the sine of this triangle? The opposite of the hypotenuse, negative 8 over 17. Good job. All right. We are going to go in the way, way, way back machine. Okay. We're going to go back to 30, 60, 90, and 45, 45, 90 just to refresh our memories. Okay. And then I have a problem that's a little bit of a challenge for you, hopefully. Okay. Probably not once I show you these. Okay. So, if you remember, if you took Mrs. Rondo, she does something about the 3 little bears, Zach and Cody, the twins, right? Mrs. Ballard, however, reteaches you in Algebra 2 Trig to use formulas. So I'm going to go with the formulas just to refresh your memory on it. It's up to you how you do it. There's obvious ratios that are in play. Okay. And I think I may have given you a really weird number on 13, but oh well. All right. So 30, 60, 90. We have the hypotenuse formula and a long leg formula. Okay. The hypotenuse is the short leg times 2. The long leg is the short leg times square root of 3. If you're thinking about the way Miss Rondeau does it with bears. There's something about this being a 2, this being a 1, and this being a square root of 3, and she uses ratios on it. Okay. All right, I've got to find x and I've got to find y. If this is the 30 degrees, remember across from my 30 is the short leg, across from the 60 is the long leg, and the hypotenuse is still across from the right angle. I just covered up my number, didn't I? All right, so what am I going to solve for first? Short or hypotenuse? Got to solve for short first, right? Because I need short in order to get hypotenuse. So I'm literally going to just take this and put it in for the long leg. So I'm going to say that my long is 5 square root of 3 equals my short, which is x, times square root of 3. This was too nice, wasn't it? All right, what do I have to do to get the square root of 3 to the other side? Divide it. What happens? Oh, wow, they cancel. That's exciting stuff. You favorite when they cancel, right? Okay, so x has got to be 5. I'm gonna let you guys get y. You should be able to apply that formula. So get y. All right, what'd you get for y? 10. Good. Short times 2, right? Okay. Now we've got the Zach and the Cody twins one. What's special about a 45, 45, 90 right triangle? What's special about its legs? They're the same. It's an isosceles triangle. Okay. That's really way back, right? Elementary school way back. So on this one, if you're looking at the ratio thing, like for the Zach and Cody and the twins part, it would be like this 45, 45. It would be 1, 1, and square root of 2. I remember that the hypotenuse equals the leg times square root of 2. This, I know the square root of 2 goes with the one with the two angles that are the same. And this one here with the square root of 3 goes with the one that has the 30 in it. That's how I remember it. All right. What's my hypotenuse? 6 square root of 2. And it doesn't matter which leg I want, right? Pick your favorite. I guess it was nicer than I thought. How do I get the square root of 2 to the other side? Divide it. Okay, so 6, it just ends up being 6. And that's also what y equals 2, right? Okay, there's one more there. Okay, I want you to take a minute or two and try to do number 14. See if you can think about what we just used a strategy up there. I promise we've done it in the last couple of minutes. Okay, see if you can figure out x and y on 14. Okay. Okay. What are we going to have to do on 14? Is it one of these triangles? It's a 45, 45, 90, but they didn't give you any indication of that other than the fact what kind of shape is this? It's a square, right? So this has to be 90 degrees. Those have to be 45 degrees, right? So it was a hidden 45, 45, 90. Okay. All right. So what is on the hypotenuse? 5 equals, doesn't matter, pick your favorite leg, times square root of 2. Okay, now what am I going to do? Divide by square root of 2. And I know in calculus we don't simplify, but on MDTP we do. Okay, so we're going to multiply top and bottom by that. So we get 5 square root of 2 over 2. Remember how in Algebra 2 trig we rationalized the denominator like 5,000 times in that class? Yeah. I always enjoy the spring because I rationalize a lot of denominators in the spring. Okay, let's see where we at. 14, 29. Okay, we good on trig? That was a really quick review of a little bit of everything that we've seen trig-wise that you may see tomorrow. Okay, any questions? All right, let's see. Let's go back to number 7 then. Okay. All right, so read number 7 to yourself. We're not going to probably do all these. We'll probably do another like 2 or 3, and then we'll see where we're at. Okay. Okay. I actually ended up writing a really bad problem, so it's not particularly good, but we're going to go with